Hello everyone, welcome to my channel. Today I will teach you a new chapter, that is trigonometric ratio of associate angles. Okay. Before starting the chapter, we just give a introduction of quadrant. So how a quadrant has been made. Suppose a fixed point O, and from that fixed point, through that fixed point, two mutually perpendicular lines are drawn. Okay. So this is O. Through this point, two mutually perpendicular lines are drawn where x, O, x dash is there, and y, O and y dash are there. And this mutually perpendicular lines divide this plane in four parts. Okay, and this each part are called quadrant, and each part are called quadrant. Okay, in quadratic geometry, you know that the distance measured from O to x, OX, is always should taken as positive. Distance measured from O to x dash always should be negative. This should be positive and this should be negative. And distance from O to y always consider as positive, and distance from O to y dash will be taken as negative. Okay. This is the basic concept of quadrant. Now, what is the trigonometric ratio of associated angles are? How it will be works. Suppose a line it will be taken, that is OA. Suppose a line, and that is a revolving line. That means it will be rotated. Okay, revolving line rotate about a point O. Suppose this line will be rotate about the point O, about this point, either anti-clockwise direction or clockwise direction. It may depends. Okay. So suppose this revolving line start its rotation in the direction anti-clockwise from the initial position. From suppose this is the initial position, this is the initial position, and from this initial position it will stretch out up to this position. Okay, up to this position. So there will be an angle formed, that will be theta. There will be an angle formed, that will be theta. Suppose after tracing out from this initial position, this is the initial position. Now the position of the rotating or revolving line OX is in this position. So if you will consider it in the anti-clockwise, rotation is in anti-clockwise direction, then the angle will be considered as theta. So angle AOX will be theta. Okay. Suppose, hope it is clear to you. And this position of OA will be depend on theta, whether this OA will be lied in the first quadrant, or say this is the first quadrant, this is the second, this is third, and this is fourth. So depend on this theta, the final position of OA will be either or in first quadrant or second or third. Suppose the theta is such a larger form, measurement of theta is such a larger that it will be OA is slice over here. Then it will be measured in this way. This is the initial position, the measurement of OA will be up to this portion. Okay, this is OA. Suppose the position of the value of the theta is little larger than this initial position, this position. So that final position of the theta will be, or final position of the OA will be this. So then initial again start from measurement, start from here, and that theta will goes up to this third position. So this measurement has been made anti-clockwise direction. Suppose now the theta is larger than this previous one, means this previous one. Then the final position of OA will be this. This is OA. Now again this OA or this theta will be measured from this initial position, and it will rotate in the anti-clockwise direction and comes up to this position. Okay, hope it is clear to you. Suppose the theta of value is theta is such a measurement that it will lies in the first quadrant. If the value of theta is greater than is larger than theta, such that it will the final position of OA will be in this direction. Then the initial position will be counted from here and theta will goes up to here. So in this way it can come from in the third and in the fourth. Okay. So suppose now I am doing this 4 position in the separate 4 diagram. So it will be more clear to you. Suppose the rotation of OA or position of OA is in first quadrant. OA. Okay. Now this is your theta, first quadrant. So if you draw a perpendicular line from here, suppose this point is P and this point is M. Okay. Now second one, suppose this is the second position. Again the revolving of OA starts and the initial position is here. Okay. So this count will be, our measurement should be from this initial position up to this final position, and it will be theta. This is OA and this is your P, this is your M. Okay. This is where, this is in the first quadrant, this is in the second quadrant of revolving line, when the revolving line lies in the second quadrant. Now if the revolving line lies in the third position, this is x dash, y dash, this is y dash, x dash, x. Now third position means here. Okay. So again the theta will measurement of theta will start from the initial position and will comes up to this. Okay. This one will be the theta. Okay. Now draw a perpendicular line MP. This is O. Okay. This is A. Now the last one, not the least, x dash, O, x, y dash. Okay. Now again start from here. Suppose this line will lies in the fourth quadrant. Then measurement of theta is start from here and goes up to third quadrant. This is the theta. So this 4 type of measurement or 4 type of position of revolving side may be. Okay. So when the position is here, you can draw the perpendicular line. Now from here you can say that, so what is the value of sin theta? Trigonometric ratio, you know the value of sin theta will be MP by OP, means perpendicular by hypotenuse. Okay, MP by OP, you know that. Cos theta will be, so this is the, you know that sin theta will be, from this diagram you know that sin theta can be perpendicular by hypotenuse. What is the perpendicular? Means if we consider this angle as theta, so opposite side will be the perpendicular and this one will be the hypotenuse. So it will be PM by OP. Okay. Now cos theta will be base by hypotenuse. Okay, base means OM and hypotenuse means OP. Now tan theta will be perpendicular by base, that means MP or PM by OM. Okay, this you know that. Now the position of this rotating line will be the sign of this three angles will be depend on the final position of the revolving line OA. How? Since OA is in first quadrant, so you know that OM should be the positive because this is the distance from the part of distance from OX, so it will be positive. And again PM also the part of the distance of OY, so again it will be positive. And this one also positive because it's lied in the first quadrant. So you from here you can say that, so PM also positive, OM positive, and this one is also positive. So PM is positive, OP positive. So in first quadrant sin theta is positive. Again for cos theta, OM is positive and OP is also positive. So in first quadrant cos theta will be positive. Now what about tan theta? Here also PM is positive, OM is positive. So in first quadrant value of tan theta will always be positive. So hope it is clear. When rotation or revolving line in the first quadrant, then or angle theta is also in first quadrant, then you can say that the value of all sin theta, cos theta and tan theta will be positive. Same for the cosec theta, because reciprocal of cos theta is cosec theta, so it will also be positive. Reciprocal of cos theta is sec theta, so it is also positive. And reciprocal of tan theta is cot theta, it will also be positive. So all trigonometric ratio, if theta will lies in the first quadrant, all trigonometric ratio will be positive. Hope up to this your concepts are clear. We will discuss the sign of rest of the ratios in the rest of, if theta lies in the rest of the quadrant, so what will be that? Okay, we will discuss that in the next video or in next class. Today's class is up to this only. Goodbye students. Bye bye.